In the introductory section of Chapter 4, we're going to talk about two distinct topics, triangles and Venn diagrams. Triangles are two-dimensional shapes with three sides, and there are different ways to classify triangles. If we classify triangles by the sides, we can have a triangle with no congruent sides. All three sides are different lengths. That type of triangle is scalene. We can have a triangle with two congruent sides. When a triangle has two congruent sides, it is isosceles. And we can have a triangle with three congruent sides. When a triangle has three congruent sides, it is equal, lateral. Lateral means sides, equal sides. If we classify a triangle by its angles, we can have a triangle where all three angles are acute, making the triangle an acute triangle. We can have a triangle with one obtuse angle and two acute angles, but since we have one obtuse angle, the triangle is obtuse. We can have a triangle with one right angle and two acute angles, but since we have one right angle, this is a right triangle. And finally, we can have a triangle where all three angles are the same. If all three angles are the same, that triangle is equal angular, equal angles. Let's move on to Venn diagrams. Venn diagrams are a visual organizer of information. And what's nice about a Venn diagram is a Venn diagram shows the relationship between that information. Now, to create a Venn diagram, we first need to come up with a universe. A universe is the part that limits what goes into the Venn diagram. In these two examples, we're going to set up our universe to be students at Delano High School. If our universe was different, our Venn diagram could look different. If our universe was students at Delano High School in choir, our Venn diagram would look different. But since we're doing all students at Delano High School, we can make our Venn diagram this way. Start by making the universe. And that universe is all students at Delano High School. So every student at Delano High School fits somewhere in this Venn diagram. Now we have some students who are in band, and we're going to put all band students inside this circle and all non-band students outside of that circle. And we have students who are in choir. So we're going to put all students who are in choir in this circle, and all students who are not in choir outside of that circle. Notice that these two circles intersect. That intersection, that union, is the place where students are in both band and choir. So we have students not in band and not in choir in this region, students in just band in this part of the band circle, students in just choir in this part of the choir circle, and students in both band and choir in that intersection. If we have three pieces of information that we need to organize, again, start with the universe. Our universe is going to be all students at Delano High School. Inside of this circle, I'm going to put all students on the math team. All students not on the math team go outside the circle. I'm going to put all the students in Science Olympiad in this circle. And all non-Science Olympiad students outside of the circle. And all the students involved in the LINK program inside this circle. All students not involved in LINK outside of that circle. Notice we have more regions. We have a region here that is just Math Team and LINK, a region right here that is just Math Team and Science Olympiad, a region right here that is Science Olympiad and LINK, and a region right here that is all three. So every student at Delano High School fits somewhere in this Venn diagram, and in this Venn diagram we have at least one student in each section.